Welcome to today's session on cloud computing architecture. In this episode, we will dive into the key layers that form the foundation of cloud computing, the components that make up cloud platforms, and how these elements interact to create a seamless, flexible, and scalable environments. So let's explore how cloud architecture works and how each layer and component plays a vital role in delivering cloud services. Again, you will see that there are some topics which is a repetition. Please take it as a revision. So the key layers in cloud architecture. These are typically structured into several key layers, each of which is responsible for a specific function or functionality and services. Let's look at each of these layers. The first one is obviously IaaS. We all know what infrastructure as a service means. So let's go through it. The infrastructure as a service layer provides the virtualized hardware resources needed to run application and services in the cloud. This layer includes virtual machine, which provide isolated environment to run a software. Software, right? This can be a dynamic application or a static application, doesn't matter. The first one is virtual machine, which is provided in IaaS. The second is storage. Well, it can provide you a block storage or object storage and even file storage for storing data. The next infrastructure is networking. It can offer you virtual networks, load balancers, and IP address management functionality, and many more things. So all these components are provided in IaaS as an infrastructure to the customer. Now, some key points. It allows users to provision virtual machine and storage resources on demand without the need to purchase or manage physical hardware. The IaaS layer offers scalability and flexibility, as resources can be scaled up or down based on demand. So that is what IaaS provides you. The next is PaaS, the platform layer. It stands for Platform as a Service. So this layer is designed for developers, and it provides a platform for developing, testing, and deploying application. It abstracts the underlying infrastructure and enable user to only focus on coding, testing, and deploying your application or the logic behind it without worrying about the hardware, the operating system, or the networking at the back end. Even the management of it is done by the cloud providers. The key components of PaaS. Well, app hosting or application hosting and development environments. Platforms for deploying and developing web apps or mobile backends is again another example of PaaS. How about databases? So managed database services such as MySQL, right, or NoSQL provided by Azure is also an example of PaaS. Middleware, tools for building and managing applications like messaging or analytics. So what are the key benefits of PaaS? Well, it speeds up deployment by automating infrastructure management tasks. Developers can deploy apps quickly without worrying about the configuration of virtual machines or other lower level resources. So even if they're testing or they're deploying it for the final run, can be done very quickly. The next is application layer, that is SaaS. The software as a service layer delivers software applications over the internet, which are fully managed by the service provider. With SaaS, users access application directly from their web browser, or in some cases, they can also use a software client or agent softwares. without the need for installation of that software itself on their laptop. So, some example includes email services like Gmail or Outlook, or collaboration of Microsoft services like M365 or O365 services, and even Google Workspace. How about CRM softwares like Salesforce? There's so many more examples. So those were the example of SaaS. Now some key points about SaaS. Here the provider handles everything from application updates to security, ensuring that the user always have the latest and the most secure version of that software. SaaS solutions are also scalable, cost-effective, and accessible from any device with an internet connectivity. So the line of sight must be there. Management and orchestration layer. Well, this layer is responsible for the coordination, management, and automation of cloud services. It ensures that all components of the cloud environment are running smoothly, efficiently, and securely. When you think about it, think about ARM, Azure Resource Manager. That also plays an important role here. Before we move to security, let's talk a little bit more about orchestration part. Orchestration simply means that someone who controls the automation, like in orchestra, right? There is a person who actually controls the whole band, right? So orchestration means the same thing. You can also call it automation. It helps automate repetitive tasks such as scaling resources or monitoring performance and handling some events or backups. So here, orchestrator or orchestration ensure that different services and applications work together seamlessly in a very unified cloud environment. The key feature of orchestration and automation is provisioning. It automates the creation and deployment of virtual resources. Monitoring and alerting can also be an example here. It tracks the performance of cloud services and trigger alarms when something goes wrong. So now you know management and orchestration layer. A lot of other tools are actually used for this. For example, Azure Monitor for monitoring and giving you alerts. Last one is security layer. Well, the security layer is a critical layer. It is critical in protecting cloud environment from unauthorized access or even the cyber threats. It actually combines a wide range of security measures, including IAM, which stands for Identity and Access Management. It controls who can access cloud resources and ensures that only authorized users have the permission. Next is encryption. Encryption protects the data at rest and also in transit to ensure confidentiality. How about firewall and intrusion detection? Well, it prevents unauthorized access and monitor for any suspicious activity. For example, you can use Azure Firewall to protect your infrastructure, and you can also use Microsoft Sentinel to keep an eye over your environment. If something goes fishy or if something looks fishy, Sentinel can actually take action. So overall, it protects your environment. Some key points about this security layer. The security layer works to ensure the confidentiality, integrity, and availability of cloud services and data. Effective security measures help mitigate risks related to data breaches and cyber attacks. Components and interaction within cloud platform can also be secured. Now let's take a look at key component of cloud platform and how they interact with each other to deliver cloud services. The first key component is again, compute or processing power. So when we talk about compute, you should remember about virtual machines and containers. These are the part of the compute component. They provide the necessary processing power to run application and services. Whether it is a big service or a microservice, it doesn't matter. The next component, which is very important, that is storage. Cloud platforms provide various types of storage, such as block storage, object storage, and even shared file storage. These services store data and application. Plus, it ensures quick and secure access over the network. The next component is networking. Virtual networks allow resources to communicate with each other. That is obvious. Here you can use many services like load balancers who distribute traffic effectively to prevent a single resource from being overwhelmed. Then you have traffic manager, front door, and so many more services. But nevertheless, they fall into this component, that is networking. The next component is database. Well, cloud platforms offer relational databases like MySQL and NoSQL databases like MongoDB for storing and managing data. You can also deploy your own database as IaaS as well. So the flexibility is still there. The next component is security. This includes features like IAM, identity and access management, encryption, firewall, and many more. All of this safeguard the data and the application in the cloud infrastructure. Right? So let's talk about some key infrastructure, right? Compute plus storage. Can you combine them? Of course. So here, compute resources such as virtual machine, access, and store data in a storage system means a machine needs a drive, a VHD, virtual hard drive. So they go hand in hand. This combination enables application to run and store their data in the cloud. Remember, now we are combining the components which we learned. How about networking plus compute? Well, networking enables communication between compute resources. Example, 2 or more virtual machines can talk to each other, but they need network in between. It ensures the data flows seamlessly between services and provide access to external networks as well. So your machines, your virtual machines, can also talk with a physical machine in your office, provided you know how to create the line of sight. How about we combine databases and compute? That is the most easiest thing to remember. Now, here, application can interact with databases to store and retrieve data. The compute resources can host websites or application, and it can connect to a database at the back end to retrieve and store the user data. So the best example is website plus database. So to summarize, in this episode, we discussed that cloud computing architecture, right, can be very complex, but the general understanding is still straightforward. And we also discussed the key layers that make up cloud environment. Each layer, such as IaaS, PaaS, SaaS, management and orchestration, and security, plays a distinct and important role in delivering reliable, scalable, and secure cloud service. We also examined that the key components of cloud platform, such as compute, storage, networking, database, and security, as well as how these components interact with each other. Can they go together? The answer is yes. Understanding the cloud architecture is very important and essential for working, especially with managing cloud platforms. And it lays a foundation for designing effective and scalable cloud solution. If you want to become a good solution architect, you must know the big picture properly. All right, so in the next session, we will explore more services of cloud. Thank you for tuning in. Take care.